Okay, so the next lesson in this unit is again dealing with parallel lines. This time we're going to do a little bit with perpendicular also, but mainly parallel. So if we think back to when we were having to write sentences, which wasn't that long ago, you'll recall that the converse of a theorem is found by exchanging the hypothesis and the conclusion. So we would start with the normal theorem. So the theorem might say, if P, then Q, but the converse says, if Q, then P. So just a little reminder there. So that's what we're going to look at now, is proving lines are parallel. In the previous lesson, we were told they were parallel, and that if they're parallel, then this happens. Well, now we're going to go backwards. We're going to be told two angles are congruent, and they have a certain relationship. Therefore, the lines are parallel. So that's where we're headed in today's lesson. So let's look at this chart here. They tell us that these two angles are corresponding. That's what this CORR abbreviation is. That stands for corresponding. So if the corresponding angles are congruent, then the lines are parallel. So they tell us angle 1 and angle 2 are congruent. Therefore, line M is parallel to N. Here we have alternate interior. This is how you abbreviate alternate interior. So if the alternate interior angles are congruent, then lines are parallel. Angle 1 is congruent to angle 2. That's what the picture shows us. Therefore, line M is parallel to line N. This is alternate exterior. So if you have alternate exterior angles that are congruent, then the lines are parallel. So angle 3 is congruent to angle 4, which means line M is parallel to line N. And last but not least, we have same side interior. And remember, if same side interior angles add to equal 180, then that tells us the lines are parallel. So if angle 5 plus angle 6 equal 180, then M is parallel to N. So that's the converse of the theorems we learned yesterday. So for this first example, they want us to name the postulate or theorem that proves R is parallel to S. Essentially, what relationship do they have? So it tells us that angle 2 is congruent to angle 6. What kind of angles are those? They're alternate interior because they're inside the line, angles. That's all we have to do. Okay. Next, they ask us about angle 4 and angle 8. What kind of angles are those? Those are alternate exterior angles. They're on opposite sides and then they're outside the parallel lines. Then we're told that if we add 7 and 6 together, it gives us 180. Which one is the one where we add things together to get 180? Same side interior angles. And last but not least, you have 1 and 3. 1 is congruent to 3. What kind of angles are those? Corresponding. Okay, next example. We have to show that angle or that line L is parallel to line M. We've got to show that. So they tell us that the measure of angle 4 is equal to 9x plus 12 degrees, and that the measure of angle 6 is equal to 6x plus 18 degrees, and that x is equal to 10. They give us all that information. So let's see what should happen here. We're given angle 4 and angle 6. What kind of angles are these? Same side interior angles. So let's see if we plug in 10 to each of these. Let's see what they get. So measure of angle 4 equals 9 times 10 plus 12. What's that give us? A 102 degrees. Then we do the measure of angle 6. Let's plug that in. 6 times 10 plus 18. What's that get us? 60 plus 18 is 78. So now let's see if we add these together. So we do the measure of angle 4 plus the measure of angle 6. It's going to be 102 plus 78. What's that give us? 180. So what's that mean about these? 4 and 6 add to 180. So let's say the measure of angle 4 plus the measure of angle 6 equal 180. So that means L is parallel to M because they're same side interior angles. Okay, now let's look at the next one. It's a similar scenario. We have to show that these oars here that make angle 1 and angle 2, we have to show that those are what? Well, what kind of angles are those? What relationship do they have? These are corresponding angles. Which means they should be congruent. So are they? Are they congruent? Well, let's check. The measure of angle 1 equals 3 times, well, x is 9. So 3 times 9 plus 13. It's going to get us 40 degrees. Let's check angle 2. 5 times 9, which is 45, minus 5, 40 degrees. So these are congruent. Therefore, these 3 dots mean therefore. Therefore, oars parallel. Okay, that's the front of the notes. Now let's flip it over to the back. These first 2 just ask us to find x. Remember what we said in yesterday's lesson. All acute angles have to be the same, and all obtuse angles have to be the same. So if we look at these angles right here, what do we notice? Are they both acute? Are they both obtuse? What's going on? Looks like they're both acute, so they have to be equal. 15x equals 12x plus 17. Now, what kind of angles are these? Again, getting practice here. These are alternate interior angles. So of course they have to be congruent. Okay, let's solve for x. So we subtract 12x from both sides. We're going to get 3x equals 17. Divide by 3, and you get x equals 17 over 3. That's going to give us a nasty decimal, so we'll just leave it like that. Okay, next one. What do we notice about these? Are they the same kind of angle, or are they different kinds? They're different kinds. We have an acute right here and an obtuse. So that means these are same side interior angles, which means they must add to equal 180. So we have to add them up and set them equal to 180. 9x minus 6 plus 3x plus 18 equals 180. Nine x plus 3x is 12x. Negative 6 plus 18 is 12 equals 180. Subtract 12 from both sides. You get 12x equals 168 divided by 12. And you get x equals 14. Okay. So now let's switch gears for a second. Now we're going to look at perpendicular lines. So two intersecting lines form a linear pair of congruent angles. If two intersecting lines form a linear pair of congruent angles, then the lines are, this means perpendicular. So if these angles are the same, that means they both got to be 90 degrees. So we can conclude that L is perpendicular to M. The next one says that if the transversal is perpendicular to one parallel line, so here the transversal is perpendicular to N, it has to be perpendicular to P as well. So Q must be perpendicular to P also. N and P are parallel, perpendicular to N, so it has to be perpendicular to P. And the last theorem, if two lines are perpendicular to the same line, then the two lines are parallel. So here we see T is perpendicular, wait, back up. R and S are both perpendicular to T. Therefore, R has to be parallel to S. These have to be parallel since they're both perpendicular to T. Okay, so let's use these for the next problem. So we have to solve to find x. Well, we're told that this transversal is perpendicular to this bottom line. So this is 90 here. But it's also got to be perpendicular to this top line, which means all of these angles up here have to be 90. So this has to equal 90. That's our equation that we need to solve. So add 2. 3x equals 92. If I divide by 3, is that going to give me a nice number? No, it won't give me a nice number. So I'm going to just leave it as 92 over 3. I don't like long decimals. They scare me. Okay, so now let's look at example 3. It tells us line V is a transversal and asks which one of these statements are true. They give us a bunch of angles over here. Let's finish filling this out so we can actually see what's going on here. So if this one is 70, 70 minus what, or 70 plus what gives you 180, because these two have to add to 180 right here. Let's see. 180 minus 70 is 110. So this angle right here is 110 degrees. Again, go through the same process for x. We have an 80, but we know these have to be 180 together. So do 180 minus 80. Gets you 100. So this is 100 degrees. Now we have enough information. So do we see two lines that both have 110 in them? Well, this line, W and Y, both have 110 as an angle. And it's the same, they're corresponding. So that means at a bare minimum, W is parallel to Y. So if our answer choice doesn't say it, then we can cross it out. B doesn't say it, so cross it out. C doesn't say it, cross it out. D doesn't say it, cross it out. Looks like we already have our answer, but just double check. Let's look at our other line, X. That's got a 100-degree angle. Z's corresponding angle is 100 degrees, which tells us X and Z are also parallel. So X is parallel to Z. A has both of those, so A is our answer. Okay, so that's the lesson. Stay tuned for the guided practice.